right, everyone. Welcome to the February 2026 Seattle Rust Meetup. It's great to see everyone again. I wasn't here last month. I was away on a work trip, and that was it was very cool. It was very interesting. We can chat about it at the break if you guys are interested. But it's good to be back as well. We're here at City Hall, and we operate under two codes of conduct. They both basically say the same thing. Please try to treat each other with dignity and respect. If you do have any issues with someone, please let them know and ask them to stop. And if you continue to have a problem, please let me know, and I can step in and help. The Discord, our Discord is available if you want to interact with anybody else in the room. We'll do lots of interactions today and maybe even afterward if you care to join us at our favorite haunt. You can join us on the Discord channel, on the Discord server that we operate. That's right there. And these slides, as they are for every month, can be found at slides.com under my technology alias U007D. I always like to do introductions. So first of all, excuse me. Just the remedy. All right. I always like to do introductions, and so just by show of hands, anybody here new to the group tonight? We have a few people. Okay, great. Welcome, welcome, welcome. And how many people here would consider themselves to be beginners in Rust? And considerably more folks. Right? So I'd like to welcome all the new folks to the meeting. And I don't want anyone to be intimidated or scared by all the other faces. It's because between a third and a half of the people in the room identify themselves as beginners, right, in this language. Some folks are beginners to computing. Some folks are veterans at computing, but new to Rust. And so you're going to find all mixes here. And I'm hoping you find the group to be very friendly, open, and approachable, because that's the type of environment we try to create. So what I'd like to do is introduce myself. You can see I copied last month. My name is definitely not Sandy. My name is Brad. And what I typically do is, with Rust is sort of low-level development. But I got my start with computing way back on a Commodore 64. And the parallels between what I was doing back in the olden days with the 64 and what we're doing now with embedded systems development in Rust are actually really similar. And it's something I've always enjoyed. But yeah, I got my start in computing in Commodore 64, went very quickly from BASIC to assembly language on the 64, which is a 6502 chip, which is a very, a very simple assembly language. So assembly language made things go fast and was really easy. And from there, I went to this interesting language called C. And then, got an Amiga, and I was on this language called C++, and did most of my career in these two systems languages. And then around 2015, as I was thinking about working on a big project, building an electric car, I said to myself, man, I couldn't do a big project like that safely in C++. And I wasn't too bad at it. So I was like, not going to do that. So ended up, I discovered Rust. I tried and dismissed, some other languages. I had tried D as well along the way. But I had bumped into Rust, gave it a shot, and it didn't disqualify itself for the criteria that I was looking for. And I said, now that's interesting, because very quickly I could find the hole in the language, why it wouldn't be suitable. And I just kept pushing on it, and it kept doing the right thing. This is the language I would have built had I had the time and talent to do it. And, I've basically stayed ever since. I haven't written any C or C++ since. So it's been a really good journey. So anyone else want to introduce themselves? You can talk about how you got your start in computing. You can talk about what brought you here or what appeals to you in Rust. I'd be happy to.
keep it short. I'm Jake Brownson, live in Gig Harbor, and just kind of looking for more. There's not a lot of technology down there, so started coming up to Seattle, see what you guys are doing up here. I'm interested in structured editing, programming, and CNC machining, CAD/CAM.
Very cool. Thank you. So anyone else?
Hi, I'm Connor. I'm a student in the area, although I'll probably be up in Bellingham for the next quarters. But I got into Rust for fun. I'm hoping to make it my career one day.
Thanks.
Stereo works too. We'd love to hear you in stereo.
Yeah. Sure. Anyone else? No? Shy group today. All right. No problem. No problem. All right. So there we go. The upcoming meetups, Thursday, March 19th. We typically meet the third Thursday of every month. And so so you can set these on your calendar. March 19th, April 16th, and then May 21st. We do publish the these dates on our Discord server. There's a calendar from the main landing in the server, so you can find those there. Just a note, I will be in North Carolina for work. 2 years been running this group, and I have never missed a meeting. And now, twice in 3 months, I will be missing meetings. So it's like, anyway, I will be in North Carolina on the week of April 16th. So I won't be here, but we'll have a backup MC here for you, and so the meeting will still take place as scheduled. Also, I have, just for interest's sake, I have been talking with some folks from Zed. They are, for those who don't know, they're a company writing a very fast Rust editor. And they want to come say hi and talk to us about Zed. So we're figuring out sort of the scope and the topic. And one of the things I had uncovered completely independently is that Zed has a connection to some very relevant technology in the world today. Zed is, that company is co-founded by two of the co-founders for Atom, ATOM. And Atom is an editor that many of you may remember from the Sublime Text days and so on. And you're like, yeah, what's the big deal? Well, Sublime Text, you know, so I think led to Atom as a sort of maybe a competing technology. And then Atom was actually, they needed some technology inside of it to run faster. That ended up, through a long convoluted story, becoming ASM.js. Is that technology stack, which became the technology stack that backs Electron today. And we all know, oh, Electron, big bloated apps, right? Which launched WASM, right, as a response to that. And the folks who wrote Atom are actually now running Zed. So there's actually a very interesting connection between, you know, Zed and WASM and, you know, other computing technologies in the day. So I hope I can get them to talk a little bit more about that. I think that'd be interesting from a historical perspective. But pretty much anything that they want to talk about a high performance editor, I think, quite interesting. I always like to take a moment to thank our volunteers. We have a group of folks who make this run smoothly. So on months where I can't be here, things just run, you know, just fine without me, right? That's really important. We also try to keep things lightweight. So it's like an hour a month, hopefully, or less for each of the volunteers. So that way it's not too difficult for any one person to help keep. So I just like to take a moment and thank our volunteers for their help each month. Thanks, guys. All right, and so after each meeting, we like many of us like to gather at Overlake Red Robin. It's all ages, so anyone can join. And if you're having a great conversation with some folks here, happy to continue it. It was an outcrop from when we used to meet at the Microsoft Reactor building, at 8 o'clock they would close and we had to like get out right away because the people there who were hosting us certainly weren't getting paid and they needed to go home. So we would stand outside in the parking lot for an hour and a half or longer. And as the weather got worse, it seemed like a worse and worse idea. So we started meeting over at the Red Robin, and it was nice to be able to sit down and grab some grub. So if you're interested, welcome to join. And you can often grab a lift if you came here by public transit. There's obviously somebody who'll be able to bring you there, and there will be somebody who'll be able to bring you back. All right. So any announcements, any Rust news that anyone would like to share with the group? Any developments in the Rust community? Breakthroughs?
I'm just curious, is anyone going to Tokyo Conf?
Or can you hit the button so it stays green?
Is anyone going to Tokyo Conf late April? We got one person.
Tokyo Conf. All right.
I assume it's Japan.
No, it's Tokyo, the.
Tokyo.
the Ace.
The other Tokyo.
Yeah.
I was wondering, like, why bring that up?
Yeah, and Tokyo Conf is here, is that right? Or
Portland, Oregon.
okay.
Yeah.
Yeah, so this is Tokyo is Rust's de facto standard asynchronous library. That's TOKIO, not TOKYO. So yeah, so yeah, it looks like we have one person going to Tokyo Conf. What do you hope to get out of it?
I don't know. We have a workshop on I really like to learn the async runtime. So they have a workshop too. So I would like to attend the workshop and learn Tokyo more. That's my main goal. And want to see. I think some more people who created Tokyo also coming to the conference. So it will be nice to see those people and do networking during that time. That's my goal. Yeah.
Would you be willing and to share with us what you learned?
Yeah, definitely. Yeah, sure. Yeah. Why not? Yeah.
It doesn't matter what level you're at, but
Yeah.
if you're like, hey, here's what I went to see and here's what I learned.
Yeah.
I think we'd all appreciate that if come back from the conference and share that.
Definitely. Yeah, sure. Thank you so much. Yeah.
Pleasure. All right. Okay, so as always, our video recording of this video will be available on YouTube, correct?
We hope.
We hope. Yes, if we get a successful recording, that's the key. For those at home, we've been struggling a little bit to get our recording set up here at Bellevue City Hall. So we're working on it though, and so if we get a successful recording, we will be posting that on YouTube, and some of the talks will also be available on the official Rust channel. And as always, we have a call for speakers. So anyone here who has a talk, or if you're thinking about a project, you want to practice, and you're going to give a talk at a conference, or maybe you're just working on something interesting and you got to an interesting place and you'd like to share that with 50 of your closest Rustation friends, you're always welcome to give a talk. Ben Dillo on our Discord channel organizes the talk schedule. So at B Dillo, BDILLO, the person that you would add on Discord, and he'll take it from there, making sure that you're all set up and any of your questions. So any questions about any of that? All good? Did I miss anything? Anything anyone else would like to add? Okay. So tonight we have two talks. One is by Carl called Device-Envoy, Making Embedded Programming Fun on the Pico and Rust. It's a beginner intermediate level, and Carl will be speaking to us for about 45 minutes. Then we'll take a 10-15 minute break while we switch computers, get some refreshments, and then we'll be talking about event-wal, which is a Rust crate to build desktop applications that never lose your data. So sounds like two interesting talks. Looking forward to them. And that's by Mark, and giving that one at beginner level for about 45 minutes. All right, so let's just give us a couple minutes to switch over for Carl. And It's neat. It's like you know that. I heard you put it about it.
So welcome. Today I'm going to talk about a new Rust crate library called device-envoy. The goal is to make embedded programming fun. It uses Rust, Embassy, and something called device abstractions that we'll talk about more as we go. I'm an open source developer working in Rust. I have a background in machine learning and some scientific programming projects in genomics. And my other favorite programming language is Python, but Rust is #1. You can also read articles that I've written about scientific programming, Rust, and related topics for free on Medium at Carl and Katie. device-envoy is an experimental library for writing microcontroller applications. The important layer that it's built on is Embassy, and what that gives us is all of Rust's async facilities. This means we can write on a, we can write on a $4 to $7 chip and write interesting programs without needing an operating system, as we call it, just bare metal. For now, the library works on the Raspberry Pi Pico and Pico 2, with and without Wi-Fi. But there's no reason that the things described here couldn't work on other chips. And I've actually done a little bit of work now. Right. I want this to be a talk that shows the library to you. So the way I'm going to present it is by giving demos. But I'm a chicken, so they're going to be video demos. I'm afraid to do them live. There is a possibility of a live demo after the main talk. Then we'll see the code. How would you make the little chip do what it was that we just talked about? How do we get the little chip to do what we just talked about? And then there'll be another demo code and so on. At each step, we'll introduce one device abstraction. An example of that is the device abstraction for controlling LED strip, like this one. And the goal at the end of this is I'm hoping you'll have confidence and maybe interest in using device-envoy for your Raspberry Pi Pico projects. So let me give you the first video demo. We're on our desktop machine. We type cargo, and I've got an alias set up so that this will download a program through the USB to the chip. Little lights flash, and then all of a sudden, something happens on the LED strip. It's a little hard to see, but through the miracle of a technology called black LED acrylic, we can put it in front of our strip, and now we can see that we've turned on the lights in a blue, white, blue, white, blue, white pattern. So how would you code that up? With device-envoy, there's some stuff at the top, some imports, but the main thing is you use a macro called LED strip. And you tell it that you want to create a new struct type called LED strip 8, and that it's going to be controlling pin 0 on the Raspberry Pi Pico, and that the length of your LED strip is 8. Now, in your main program, you immediately call your inner main program. That's a trick I learned from Brad, and that lets us return error results in our inner main. Nothing to do with device-envoy, but I still think it's a good way to code these things. So in inner main, we initialize the hardware, and then we use our struct type to create a struct instance called LED strip 8, and we just pass it the resources for the Pico. We pass it the pin, and there's some other resources, something called PIO 0 and DMA channel 0, and that gives us a little struct. Now that we have a little struct, we're not going to use it quite right away. Instead, we're going to create a frame, a 1D frame, which is really just an array of 8 RGB pixels. We'll also create an array of 2 colors, and we'll do a loop where we go from 0 to the size of our frame, and for each position in the frame, we'll set that to either blue or light gray alternating. That's what the mod 2 does. Okay, so now we've got this array set blue, gray, blue, gray, blue, gray to actually write it to the LED strip. We use the write frame method. We pass it this frame, and it'll appear. The LED strip will do what we want. It'll stay showing those lights indefinitely. We can go and do other things at this point. And in fact, we want this program to run forever. There's a bunch of ways to do that on microcontrollers. My favorite is to use the future pending. Wait, that just says we're never going to return if we're on it. So what was the device abstraction in this case? It's a software encapsulation that from the user's point of view is just a struct with normal kind of methods and async methods. Nothing special as the user sees it. Behind the scenes, the struct is sending messages via channels and signals from Embassy. There's also an Embassy task running that's running in a loop, and it's processing these messages that it's getting from the struct. The task also can own resources, which is the hardware in this case, and can hold all kinds of state. We'll need to anchor this somewhere. There are different ways, but they all come down to just saving it, assigning it to a static variable. And that means that it'll exist for the full lifetime of the program. And if you'd like to see something more about how this works, about a year ago, Brad and I wrote an article, How Rust and Embassy Shine on Embedded Devices. And, talks about this, the idea of device abstraction. Okay, let's be a little more ambitious. Instead of just setting the lights, let's have the lights blink. So how would we write a program to do this? Very similar to the previous program. Everything's set up the same, except now instead of one frame, we're going to have 2 frames. And we're going to set the first frame exactly the way we did before, but we'll set the second frame offset 1. So where the one was gray, the second one will be blue, and vice versa. But there's also a new method here. There's a method called animate. So we can call the animate method with pairs. Each pair is a frame and a duration. Another frame and a duration, however many you want. And what it'll do when you call animate, it'll show the first frame. It'll wait for that amount of time. So the second one, wait for that amount of time. And then it'll loop back and show the first one again. So it'll just keep alternating between those two. And again, this plays in the background. So if you want to then like be watching a button or something, that's fine. This your LED strip is going to be taking care of itself. Okay, this is a panel, an LED panel. It doesn't look like an LED strip, but it's still an LED strip. This is still light 0, light 1, light 2, light 3. It zigzags back and forth. You can plug 2 of them, or 3 or 4 together. What's shown on the screen is 2 of them plugged together behind the black LED acrylic plastic. This program, we want to have a little gray dot, zigzag, zigzag, zigzag through the whole screen. Like so. Okay, so let's see how we would code that. We're still going to use the LED strip macro, and we're going to create a struct called LED strip 96. I'm changing which pin it's plugged into just to show that it doesn't have to be in 1. I tell it the length like I did before, but now the length is 96. These are optional inputs to the macro. Optionally, we can give it a different PIO resource. It defaults to PIO 0. We can specify a non-default DMA channel, here 5. 96 LEDs is a lot. If each one runs at full brightness, that's about 6 amps. And if we're pulling our power through the Pico chip, it might not be good for our microprocessor. There are other ways you can set up the power supply, but that's the most convenient way. So by default, the library is going to limit us to 300 milliamps. But here I feel safe by bumping it up to 500 milliamps. So I've given it an optional parameter saying it's allowed to use up to 500 milliamps. Also, the colors on an LED aren't the same as the colors you'll see on a TV screen or a video monitor. And if you want the colors to be accurate, you have to do a color correction step, which is a parameter called gamma. There's a default one that it's usually running, but there's also an alternate one that's compatible with the library, the smart LED library. Finally, for this animation where it's going through all 96 pixels, 96 pixels is kind of a lot. And if I have 96 frames of animation, that would be a lot of memory if I want to run it in background. So I'm not going to run it in background. I'm going to do that I'm not going to use the animation command. I'm just going to do things one step at a time in the foreground. So I'll set my animation frames to 0. A nice thing about both the gamma correction and power limiting is they all compile down at compile time to just a simple lookup table that dims the LED lights and appropriately and is very efficient at runtime. So there's some more code here. We need to instantiate our LED strip 96 instance. We pass in pin 4, PIO 0, DMA channel 5. What happens if we messed up and we were still passing in, say, pin 1? It's fine. The compiler will catch the error for us. If what we said when we declared LED strip 96, which was that it needs to work with pin 4, if we then try to pass it any other pin, we'll get a compiler error. So that's nice. To actually do the animation, I'm going to create another 1D frame, but now I'm going to initialize it to blue. I'm going to loop through for every index position one at a time. I'm going to turn that one index position from blue to gray, except nothing's changed yet. Then I'm going to write that big string of 96 RGB values out. So one will be gray. Everything else started out as blue. I'll have a little timer. In the array of colors, I'll set the one that I set to gray back to blue, and then I'll go through the loop and I'll set the next one to gray, and so on. And that's how we get this foreground animation. So I think that's fine, but what gets annoying is imagine trying to write a word of text onto a thing like this that you have to address in a zigzag fashion, or draw a circle or a line. It's literally a nightmare. So here's a demo where we're going to do that, and we're going to see how it works. Downloading our program, and we're just writing the word go-go to the display in white and in colors. So let's look at how we do text to a 2D LED display with the device-envoy library. The first thing we have to do is tell the program how this crazy display is wired. So this is actually a standard wiring, serpentine column major. So we can just say that we have an LED layout of that type and that it's 12 by 4. And that is sufficient to give us a constant that describes this. But what I actually displayed was 2 of these connected together, so we can use a combined vertical and combine 2 of those layouts together, and we get a new layout that's 12 by 8. That's nice, except we wanted to display things sideways, so we just tell it to rotate counterclockwise. And the nice thing about all this LED layout stuff is it's all done at compile time. So there's no runtime cost to describing the LED. Also, if you don't want to use my cute little mini language here for describing LEDs, you can also just list the X and, like for every pixel in your LED, you can just list their X and Y coordinates if you want. And that's a perfectly supported way to describe how your LED is wired. Now that we have that, we're going to use a new macro called LED2D to define a struct called LED 12 by 8. It also connects to pin 4. It uses the layout we just said, and we can specify a font that it uses. And the library has a bunch of fonts that it got from imported most of from the Smart LED library, except we also have a version of all the fonts called Trim, where we have the letters packed together, no space in between them, which is useful for these very small displays. And then later on in our inner main, we've already created our LED 12x8 instance, and we just say write text, and we just give it the string of text. Go, new line, go, and we give it a list of colors, gray, orange, pink. And when we do that, what we saw gets displayed. As far as the colors, if you get it too many colors, there's one color per character, but if you give it too many, they're ignored. If you give it too few, it'll wrap around and recycle them. And if you don't give it any, it'll default to white text. Okay, so that's go. But what if we wanted to draw lines? Now what are we going to do? And what if we wanted to fill in the center of the circle? So that would look like this. So how do we write text, set particular pixels, and draw lines? See how that goes. We're going to create a 2D frame. It's going to know what size to be just through Rust inference, because at a much at a step way far down, this frame is going to be written to our structure that's 12x8, and because of that, it knows that it needs to be 12x8. We're going to write text to that two-dimensional frame, go, in these colors. We can use X and Y coordinates to just set particular pixels to particular colors in the 12x8 array. And thanks to a wonderful crate that we're integrated with called embedded graphics, you can do all kinds of geometric things, lines and circles, other kinds of text besides the default text font that you set up. You want to draw lines, which is what we're going to use it for here. The first step is you give it a line style. This is, again, all part of embedded graphics. You say you want it to be red. Its way of describing colors is a little different than the Smart LED way that we were using. So there's a conversion, but it's compile time, so there's no penalty. And we want our red line to be 1 thick. Both our frame and our LED struct know their size and their dimensions. So if we want to find the coordinates for drawing our line, we can ask how high is it and divide that in 2, and that'll give us the midpoint of the Y coordinate. We can ask for where the bottom left is, what point that is. We can extract the X or Y coordinate from that. And with that, we can get the coordinates for the middle left, the middle right, and we'll already have the 2 bottom coordinates. And that's all we need to draw a line from here to there and from there to there. All that goes into the 2D array, which is now all created, and we just call write frame, and it gets displayed. So that's 2 of the device abstractions, LED strips and panels. You saw they were both built on Embassy. They're built on other libraries like the Smart LED and the Embedded Graphics library. They have features I didn't show, like on 2D, you can animate 2D stuff too, just like you could for the 1D. And the limits are really the limits of the hardware. You can control on a Pico 1 up to 8 LED strips independently, and on the Pico 2, you can control up to 12 of them independently. So let me tell you about some device abstractions that are in device-envoy, but that I don't have time to describe. My favorite one that I'm not going to talk about is an audio player. The audio player will play audio clips to little I to S boards, which you can get for a few dollars and just have 3 wires that you connect in. And the audio player device abstraction supports compression and runtime sequencing and real-time volume control. There's a flash array device abstraction that gives you type-safe persistent storage into the microcontroller's flash memory. There's a servo device abstraction that lets you position a motor, and just for fun, it supports animation too, so you can come out with a whole sequence of angles and times, and it'll do the dance and move them all. There's an infrared receiver that's supported. It actually looks like that. It knows how to decode the most common protocol, but when you do that, all you get is some kind of ugly hex numbers. There's another version of it where you can give it a table and say if you see, when you set it up, and then whenever you push the button, you'll actually get a nice enum variant. It says, oh, that was a number and it was 3, or that was the stop a push. A year ago, when we were doing projects in this group with the LEDs, or with the Pico, we were using 4-digit 7-segment LEDs. There's a device abstraction for that. Another common thing people use is a character display. We support that. You might not think buttons need a device abstraction, but maybe we want to know whether the button's been pushed for a long or a short time. And we wanted to do some debouncing, which is getting rid of some of the mechanical noise. All that, not that hard to do, but it's still very convenient to just not have to do it at all by having it inside a device abstraction. And another one is the clock sync. So clock sync doesn't have any hardware associated with it. It just keeps the local time, and every so often it uses Wi-Fi and calls the time server and makes sure that it's synchronized. Pretty cool. Okay, Wi-Fi. How do we get Wi-Fi? So for $1 more, when you buy these chips, they have Wi-Fi, but it's a little bit annoying to program. And there's a million things you can do with Wi-Fi. But what you mostly want to do is get it to connect to your local Wi-Fi connection network, and then have this network stack that you can do things with. So, and one way, and it's kind of annoying. Like, how do you get the name of your local Wi-Fi network and password in? Well, you can compile it into your firmware and download it. That's not very flexible, and it also might be a security problem. Here's a better way. You power up the chip, and it says, use your phone to connect to me. And over your phone, just tell me what your Wi-Fi ID and your password are, and I'll save it. And then I'll reboot, and then I can connect. And here's what that looks like. Here it's displaying join. I connect with my phone. I look down. Oh, look, there's a Pico demo Wi-Fi provider. So this is like running Wi-Fi. On my Android phone, it says sign in. So I click that. It brings up a web page being served from this little device. I type in my Wi-Fi network. I type in a password. Hey, it's not my real one. And then this thing resets itself and then tries to connect to that local Wi-Fi. And after it connects, it will do a DNS call on Google and print the last 4 digits of the DNS address. And then every 15 seconds, it'll do that again. So what happens if we have this set up and we unplug it and plug it back in? You have to give the password and stuff again. No, it saved it to flash. It'll just try to reconnect. But maybe you moved it to somewhere else, and you don't want to connect to your old Wi-Fi. In that case, you hold the button down. That's what the button's for. You hold the button down, and now when you do that, it will go right up to the back to join. Thank you. Also, if it tries to connect 3 times, it fails.
Thank you.
If it tries to connect 3 times and fails, it'll also go back to join. So how hard is this to program? Not that hard. First, you set up the flash memory thing, which I said exists. I won't describe it here, but it's just setting up the typed flash memory for the Wi-Fi credentials. Then you create a Wi-Fi auto new. You give it these pins that are fixed in the Pico 2W for running Wi-Fi. You could give it a PIO resource, a DMA resource, those flash credentials. You tell it where your reset button is and which way you've wired it. You tell it the name of the local SSID. And if you want, not used here, but you can give it more things to display on that Wi-Fi sign-up page. And you can ask for things like the clock asks, what time zone are you in? It has a giant HTML pull down of all the time zones. And you can do whatever you want to get additional information there. Uh, Wi-Fi Auto, the instance, only has one method called connect. So it's going to try to connect. It will launch the setup app if it needs to, if it doesn't already have credentials. As it gets credentials and has to switch modes, it'll reset as needed. When it's all done with connect, it will be consumed and it will return a network stack and give you your button back to use as you wish. And Wi-Fi Auto won't exist anymore. While it's trying to connect, it'll spit out events, and you can give it an event handler if you want. So you can say, well, when the captive portal is ready, write to whatever your display happens to be, join. When it's trying to connect, run this little animation program to show that it's connecting. If it's failed, write's failed. And when it's finally connected, maybe you want to cache this. Let me just show you what the DNS code looks like. This is mostly just nice embassy. There's not much of my own code in here. But we create a fixed memory string. We call, with our stack, we call DNS query. If we get the right kind of result back that does exist, that didn't have an error, then we pull out part of the IP4 address, format a string. If any of those things didn't happen, we create our dash 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 string, and then there's a method called write text to a panel with the colors. I think we saw that before. And then it waits 15 seconds and calls the DNS server again. Okay, that ended the parts where we're going to see the code. I want to show you 2 more demos, and then we'll do a little finishing up. So here's a demo of 3 different clocks with different kinds of displays. So they already have their local password. So they're all trying to connect, and they all have their own way to tell us that they're trying to connect. And as they connect, they get the time from, they know what time zone they're in. They get the time from a time server and then display the time. Now it's showing the time in hours and minutes. And you can see each of the displays shows it appropriately. This is programmed so if you push the button, it switches to minutes and seconds. Oh, and the clock here, these servos only go 180 degrees. And it's like I don't have gears. I don't have a 3D printer. So this is, you could call it like an elevator indicator is the way it's telling.
Resistors.
Yeah, I'm using resistors to make the arrows a little bit longer. If I find someone who really is good at hardware and wants someone who's good at software, then it would be good if we worked together, because I really only care about the software part. Here's one more demo. This is a demo that hopefully I'll be able to show live after the talk. This is Conway's Game of Life, which is a cellular autonoma simulator. Each cell lives or dies just depending on a simple rule about how many neighbors it has. So in the 16 by 16 LED panel. So this is called a glider. This pattern is well known to kind of move across, but we also work with the IR remote, and we can make it go faster by hitting the plus button, hit the plus button again, it goes faster still. We're going to hit, there's a pause button, so it freezes. There's a step 1 button. If you hit the mode button, it'll change color. Oh, sorry, going back to regular speed. Hit the mode button, it'll change color. And then each of the numbers is set to a pattern that's kind of known to be interesting with Conway's Game of Life. So that's the glider, that's the default one. But if we skip over to 2, we get this one, this one, this one. I didn't learn any of the other names. A couple of them are weird because I define the screen so that something's a neighbor if using Pac-Man rules. If the edges, it wraps around the edges, that counts as a neighbor. It's not the normal way to do it, but it does come up with some interesting patterns because of that. The last one just puts random dots, lets them evolve until the number of dots hasn't changed for 15 generations, and then it just sets another LED, another random pattern. So that makes it kind of fun. Maybe I'll put that up on my wall. Okay, so this is what device-envoy gives you. Let's take one example, which is the LED 4-digit 7 segment clock. When we're running that, We've got the LED needs to do something called multiplexing, which we won't talk about, but if you played with this last year, it was kind of annoying. We might want it to blink, like if we're changing time zones or something. Every second or every minute, we're going to want to update the time. Separate from that, we want to be watching a button and we want to see whether we're holding the button down a short time or a long time. Separate from that, we've got this clock ticking so it can tell us when there's a new time segment. Separate from that, we've got this network connection that every so often we want to go out and connect the network. If you were to write a clock at the lowest level out Rust with timers and interrupts and shared state, it would be very annoying and it would be dangerous because maybe you accidentally assign the same PIO resource, whatever that is, to two different things that need it. And now they don't realize it because nothing stopped them, assigning it twice. Just by using Rust, we get safety on our hardware, and we get type safety in our general program. So Rust gives us safety, but this is still going to be a very annoying program to write. It'd be very fragile. Any little change would be very hard to change. Embassy moves us one big step up. It gives us all the async building blocks of Rust. The ones we're using the most are tasks and channels and signals. And it means we can really do interesting things like this without having an operating system. These things that we're writing off to the chip are quite small. Device-envoy tries to adds another layer. It's encapsulating the embassy mechanisms into device abstractions. Our goal isn't to cover 100% of everything you might want to do with Wi-Fi, but if we can cover 75% of what you might want to do, which I think this Wi-Fi Auto does, and make it super easy, then we've done a lot. And if we're missing anything, just create another device abstraction that covers another chunk, and eventually we'll get most of the interesting stuff done. That lets us explore what I think of as application level programming on bare metal. And by that, I mean, it actually, I hope, moves us toward making embedded programming have the simplicity of GUI or web development. Now we can program at a kind of high level that we think is appropriate for these kinds of programs. Last slide is a call to action. The first thing I'd love is anybody using programming Pico who's interested in Rust or wants the safety of Rust, use device-envoy and build some cool Pico projects. The whole project's on GitHub. I think I've spent more time writing the documentation than the code, so I believe it's reasonable to use. If I don't have every device abstraction here, so if that's of interest to you, help me expand the library, creating new device abstractions. And this is only running on the Pico. If you're really interested in something else, take these ideas and get them running on other microcontrollers. And the article is a good place to start, plus the code in the project. Right now, there's a forum for this idea of application level embassy development. And it's not just for using this library, and it's not just for the Pico. It's for anybody who's interested in application level programming on Embassy. Right now, its home is just the GitHub discussion, but if anyone's interested in it, let's start there. And if enough people are interested, we'll find a bigger, better home later. And finally, if you want to see other things I've written about Rust and scientific programming, check out the Medium. Hi.
Very cool, Carl. Thank you for sharing that. Q&A?
Obviously, that's fairly interesting to me. So I haven't got to play too much yet with Rust on embedded, but Embassy is still very device specific. Is that part of what this is starting to address? Is that why this is only on Embassy?
Embassy does need to be ported to each microprocessor one at a time.
Mm-hmm.
Pico 1 and 2 are two of the ones that have pretty good support, but they're not the only ones that have good support. I think some of their families might even have better support. So it's not everything runs Embassy, but more do.
Okay, So if something runs Embassy, can you use it with Envoy?
Envoy is written, the problem is the things I was thinking about, DMA resources and PIO, whatever those are, they're specific to the Pico.
Yeah. Okay.
So if you want to run most of these things, they actually are, these chips are basically their own operating system.
Yeah.
And Embassy has to be customized to them, and device-envoy has to be customized to the flavor of C that is written on them.
So you could perhaps in the future get to a point where you had your device envoy on multiple chips, and then device envoy being a device abstraction could just write in that code and then twiddle some configuration bits.
You would hope so. If it's for a lot of these, for example, when some of the things saying when we just like creating an LED strip to give a PIO resource, well, that's not going to be an input for it that doesn't have PIO. I mean, the worst case is we'll take as much of the design sense as we create into a new thing. Best case is maybe we'll get portable code. I don't know in between those.
All right. That's interesting. My other thought is bare metal is kind of unfair to call that bare metal when you have this kind of tasks and things. I think you need names between operating system and bare metal.
Yeah, I don't.
Right now.
Here's the thing. It doesn't use it. Nowhere is it allocating memory, for instance. So that's pretty bare metal.
Yeah, I think it's important to remember that even in the Embassy ecosystem, all the abstractions in here, they do compile down to sort of what we used to write in C or, a very low level, the same language instruction, which is why we want to write at a high level, but get all the benefits of writing low level. A C programmer would look at that's not bare metal, but the reality is we compile down to it's actually what they would be writing by hand. Pretty awesome. We're kind of spoiled that way, so cool.
At the risk of going off topics from LinkedIn, that you have a Kevin Bacon number, could you tell?
My Bacon number is 3 because my son is a filmmaker, but my air dish number is also 3. So the most impressive thing, my air dish number is 6. Air dish is scientific publications. You have to go off to get someone who's authored something with the mathematician air dish.
Probably the most prolific mathematician because he was high on speed all the time.
That was a really great talk. I feel like I missed a keynote. Is there cross compilation happening here? Is there's like a thing running there that's getting signals from the rest that's running on the desktop?
No. There is cross compilation. Sorry, cross compilation. The MyRest desktop, which is a Windows subsystem, Linux subsystem for Windows, is compiling to the flavor of ARM that it knows is on this chip. And then I just run a shell script, which I've aliased to cargo, that just copies the firmware that it created to here. And then after that, all what this has to do is get power. Nothing is running on the desktop after the compilation has finished.
I'm curious to check my thing. So Embassy is not an operating, but sort of a communicate framework that then runs on the hardware, and then we're sort of running, having code that interface with Embassy to have little sort of tasks that are
correct. Think of it as a really simple thing. If you want to set a timer at the lowest level on one of these, you've got to set an interrupt, whatever that is, with a callback, whatever that is, and all this. With Embassy, it does that for you. So you just say timer dot, I forgot the command, sleep or something, through 400 milliseconds, and it does the interrupt and whatever, but you don't have to see that. And likewise for tasks, it's cooperative multitasking. So if you really want to, you can mess up your own program, but it's still giving you multitasking on a single processor with nice responsiveness.
This may just be outside the scope of the talk, but I'd be curious, could you throw up the source for one of these things that and shows how it interfaces with Embassy rather than just showing usages of it? Or is that too big for a Q&A?
I think it's too much here, but the source code's, you know, all there.
Great talk, Carl. And yeah, good to see you again. And last week, I think we were talking about dinner. Last month, we were talking about dinner about like teaching Rust through the use of microcontrollers. And I think this is a very relevant talk from that regard. I'm just trying to figure out like if we were to like pick on, you know, Arduino as a application framework, right? Like it uses C and it has all this UART and debugging that kids could use in school, and you know the teachers could easily point out and say, hey, if you want to debug, trace debug to this UART thing. Do you feel like Embassy and like your like Envoy have some level of like trace debugging for someone who's trying to figure out why something's not lighting up if it's a hardware problem?
Yes and no. If someone is programming microcontrollers with Python right now, they've basically got a runtime operating system on their running on the chip, which makes it very convenient, but also runs 10 or 100 or 1,000 times slower than what we're getting here. With a debugger, which is a $12 gadget and plugged into, and this one, a port right there, you can set breakpoints, which I don't do very often, but you can also get trace messages. You can say info exclamation mark and get trace messages going back to the console. I use VS Code. So I find the debugging very natural, and it, you know, I said my goal is to make it as easy as GUI or web programming. We're not making it any easier than that level of application programming.
And when I say student, I also mean agents, which will also use the same functionality to debug things.
Yeah, actually AI loves this stuff. Just like people having the right level of abstraction makes it much easier for the AI to create. I mean, the AI already knows the idea of things like Conway's Game of Life, but it has to know how to display things to this hardware. And when the abstraction's at this level, it can do it pretty straightforwardly and efficiently.
And just sort of related to that, do you run into any challenges with like using each cycle, like because it has limited, you know, set of cycles in a given?
The only time, for a while, I was running an RFID reader. Oh, I forgot to list that. I have an RFID reader, device abstraction too, and the IR, and some LEDs, and like everything I could cram on, every little thing I owned. And it was running a bit slow. What I did is I moved the code for decoding the IR into the programmable I/O that the Pico offers. There was already some sample code written. It's in PIO assembly, but with C calling it, and I got it poured over to run in Rust. And now the decoder runs perfectly fast, and it needs to do microsecond timing, so it's going great.
I see, Daniel, you have your hand up?
Oh, there we go.
Yeah, can you guys hear me?
We sure can.
Okay, yeah. First of all, great presentation. This looks really interesting, especially because I just got a Pico in the mail a couple of weeks ago. But yeah, this looks like a really great educational resource. I'm wondering if you'd be interested in, like, you know, contacting the Teach-RS group and seeing if they would be interested in helping, you know, put together some additional, like, embedded programming course content to go along with this library.
Sure, that would be great. And I think the video that we're making from this will kind of be the coming out party for this library. So I'm hoping everybody who's interested will kind of let me know.
Yeah, just so you know, I posted the link to the it's the Trifecta Tech Foundation, Teach-RS. It's just on GitHub. Yeah, if you want to take a look there.
Okay.
I'm not sure if you've connected anybody there already, but yeah, it's in the meetup channel on Discord. So.
Okay.
Yeah, excellent work. Thank you.
Thank you. I'll follow up.
Great, and just to wrap this up for time, it looks like I'll read Paolo's comment here. It says that there's many Rust embedded books online that cater to specific boards, microbit, ESP32, etc. Here's the one that covers the Pi Pico. It has examples for using Embassy as well as lower level. So there's a link in the Teams chat that may have some of the source code you were asking about earlier, at least some examples for the source code you were asking about earlier. The Embassy library also has fantastic examples, a lot of them for a lot of the different boards it supports. So look in the examples subfolder in the Embassy crate or in the Embassy repo, and you'll see many, many examples for how it's done. All right, one more round of applause, please, for Carl.
Thank you.
I think September or October, I gave a very loosey-goosey presentation on building a DAW in Rust. And this is kind of one part. Oh, a DAW, what's a DAW? A digital audio workstation. So if you're making music, that's kind of like Photoshop for making music. Hopefully this will work out.
I think it's working even.
Okay, all right. Yeah, and so I want to share something with you all that I built that kind of resolved some major friction and pain points that I had during that process. And I really wanted to call this crate Walrus, but somebody else had already taken that. And it's doing something very similar, but it's doing it for a distributed system. And this is not meant for a distributed system at all. But anyway, we'll get into talking about this. The other kind of funny title I could have chosen for this was Lookma no file save command. But we'll get into what that's about. So I don't know if everybody's met me before. My name's Mark. I've been an engineer for about 30 years. I got into digital signal processing a couple of years ago. Now it's turned into a hobby thing. I absolutely love it. I'm a musician, so I make music, and I just love the intersection of making music and technology. And it consumes enormous amounts of my time. But it makes me happy, so it's lots of fun. I learned about Rust back in like maybe 2018, 2019, and I tried to learn it. But I didn't really actually earnestly start learning it until about 4 years ago. I've used it in production, and I love it. It's great. Yeah, so just a couple of disclaimers just for reasons. These are my own opinions and work, not my employer's. And just as a disclosure, I use AI coding tools regularly. I have a spectrum of how I approach writing code with AI coding tools. And I've written production code that is completely created from AI coding tools. And I apply a very different review bar to that code than I have here. This isn't vibe coded, but it is not production ready. I haven't reviewed everything. It's directionally good, but also AI helped me write the slides. I'm pretty lazy. The architecture, design, and direction of this crate, completely mine, including all of the bad ideas and the mistakes. But the code was generated by AI coding tools. Again, this is I would say this is highly experimental. I'm sharing this for a few reasons. If this inspires anybody and folks are interested in collaborating on it or maybe thinking about using it, just, hopefully we'll see. So again, why did I build this? So I was working on my DAW, and every time I would change the persistence format for the project files, this is obviously in major development mode right now, so everything is changing. I would lose all of I would have to redo all of the test files that I had for this. And I have no idea, to be honest, I started with this about 12 months ago, and I had no idea what I was doing. So there was a lot of change friction, and I got sick of it. And so I said, okay, I'm gonna take a break from working on the DAW for a little bit, and I'm gonna fix this problem so that it's not an issue for me anymore. And it's worked. It's been great. I haven't looked back since. And the test projects They survive changes. You'll see why when we talk about the storage format. And the other cool thing is you might think that I'm writing the DAW in Rust, and so why is it crashing? Well, it's because there are the ecosystem of plugins around digital audio workstations. They're all written in C++ for the large portion of them. And I'm bringing in these plugins via shared objects, and they run in my process space. And so if they do something wrong, down goes the whole process. And my code is buggy, so there are some crashes that tend to happen. But anyway, it's really annoying, losing work. So the problem here really isn't just about my DAW, though. I write music and I use all sorts of different production-ready DAWs, but the reality is that they crash too. And so if you can imagine, I'm working on a song and I'm in the zone, and 3 hours have gone by, and I'm just way more interested in trying out new ideas, and I forget to save. It crashes. It's gone. Maybe some of the audio that I recorded is still around, but it's painful. And this might sound familiar to some of you. I don't know, raise of hand. I couldn't believe it, but when I was working on my performance review this year, I'm typing it in and the tab gets closed or something and it's gone. It's like, I'm seeing some head shake, like this is still going on. So I end up going to NeoVim and writing my review in NeoVim and then copying it over. It's like, this is kind of annoying. It's like 2026 and this is really still a problem. Some apps get this right, but they don't get it right for the reason that you would think, like Figma and Google Docs. They get this right because their purpose is to enable collaborative editing or multiplayer mode. And so the way that the data is flowing is already going through a persistence system. And so they kind of get this crash recovery for free, but they're also paying a pretty hefty cost for implementing CRDTs if you're familiar with what those are and implementing that. But desktop applications, we're still gambling on autosave timers today. So this bothered me, and I decided to do something about it. It was bugging me, not just with my DAW, but it also really bugged me that this is still a problem with most desktop apps. So my goal is to build something that solves my problem, maybe inspires other people to think about crash resilience differently, and to get rid of that file save thing. And maybe this evolves into a useful tool for others. I have thought about what the right foreign function interface layer might look like for this, so it could be useful in other contexts. I'm pretty sure that everything I'm using in here could be no standard, so that shouldn't be a problem. If it is, then it's pretty close to get there. So what I needed is I wanted crash resilience, every change durable before it's applied. So when you get that feedback in a UI that a change has happened, I know that once I see that feedback in the UI, that's on disk. And there are some other things that I want here too. I want undo and redo. I don't want to have to implement undo and redo for every application that I'm building, or for even every prototype or demo that I'm working on. I also want deterministic replay. One of the cool side effects of this is that I get reproduction steps for free now. So if I do have a crash in one of the apps that I'm working on, I have a test case right there. So I can replay that and figure out what happened. And this is also real-time friendly, and I'll talk about why it's real-time friendly, because I think the astute folks that understand how write-ahead logs work with fsync is still pretty expensive, but I'll show you why this is real-time friendly. So I'm going to walk through a demo here. And this is a spectrogram analyzer that I built. And I'm just going to show how this works. So let me get the right, okay, so right now I have a dump tool that shows what's in the write-ahead log, and there's nothing there right now. So I'm going to import some audio, and we'll get the keyboards in here first. Okay, so now you notice I just imported the audio. Here it is. The spectrogram's been analyzed, and the wall has an event written to it. So if I add another track, then we see that we've got another event here. And so we're adding a layer to this. And then I'm going to just quickly go through and add a couple of other things here. Get the vocals in. I need to implement multi-file import. I don't know, did I do the drums yet? Yeah, okay, cool. So, so we see all these layers down here, and we get, and I'm not hitting save or anything like this. This is just all happening within milliseconds. This particular app, I think, is forcing an F-sync, and I'll talk about that a little bit later. So every time I do something in this app, it's on disk. But I also get undo for free. So all that undo is, I'll do an undo here, but the wall didn't actually change, and I'll explain why that didn't change real quick. Let me see if I get the right one here. What's that? Because I what? Exactly. So I don't have the right terminal up, but basically what's happening is undo and redo is modifying where a head pointer is. So like there's a sequence right here for these events, and then all that we're doing when we do an undo and redo is changing that head pointer. So I can actually back out of this all the way, and we've got nothing, and then we can get back forward into this. And this application did not have to do anything to implement undo and redo. Got it for free. It does have to implement serializing a snapshot, and it does have to implement serializing the event to JSON, and then it does have to implement reversing an operation. I'm not going to be able to get into that one too much with the time that we have here, but happy to chat about it. So the other thing here, I'm not going to be able to have a really good demo for this, but the other thing that I do as a creative when I'm working with making music is I have a project that sounds pretty good, but maybe I want to do something substantially different with it, but I don't want to lose the progress that I've made on it so far. And most DAWs don't support this workflow. For engineers, we know how to do this. We do git branch, right? So this doesn't exist for digital audio workstations. And what I would want to do is say, hey, I want to create a branch, explore something here, and maybe throw it away, but I want to be able to come back to this thing. I don't have this implemented in a demo yet, but this supports creating checkpoints and branches. So yeah. So like the next thing that I want to implement is a UI that lets you explore the whole structure and then navigate through it. And so the cool thing is that you can click it to any point in the lineage in any branch, and that will immediately apply in your application state. But the UI side of that just isn't implemented yet. I have tests proving it works. But so how many people are familiar with what a write-ahead log is anyway? I think maybe it would be good to, okay, so about 50-50. So everybody knows what a database is, like Postgres or, and this is true of almost any database, a graph database, an object database, a document store, anything. Almost every storage technology is built upon a write-ahead log. And let me get this down just a little bit so we can fit all the code. There we go. This is the basic algorithm of a write-ahead log. So we have this function, apply action. And what we're doing here is this is very naive, it's just for a demo. We're passing in our global application state, which is a bad idea, but anyway, it's just a demo. And then we're passing in the action or the mutation that we want to apply. And then we have this file that we're writing to. So basically all we do is we serialize the action into bytes. We write those bytes to disk. We synchronize using the operating system F-sync mechanism. And then we apply the state to our application. And so the user will get this feedback. If the UI looks good, they know that that has been persisted. And then recover is actually a normal operation. It's the same as opening the write-ahead log. Those are indistinguishable from each other. So when you want to recover from a crash or you want to open a project, You just recover from it. And what happens here is you walk through the wall and apply every event that's in the log. So this basic pattern works, but like I said, we need undo, redo, lineage tracking. There's also a problem. You can imagine that you could end up with a log that has millions of events in it, and it is a problem. Now this replay or this recover or this load is going to take a long time. It's one way to get around that is to take snapshots. So periodically, so the way I've set this up is the host, which is the application that's using this library, the host can configure how frequently to take a snapshot. So you can say every 1,000 events, let's take a snapshot. Or for every 12 megabytes or every 10 megabytes, whatever in terms of size. So you can either do it on the number of events or the number of bytes that have been put into the log. And then, yeah, so then those snapshots, so when you do that recover operation, the crate will first look for any snapshots and then start from the latest snapshot. And it's tracking when a snapshot is created and what that points to in the log. The events can be different formats. So I think I'm supporting JSON and CBOR. I didn't know what CBOR was. I think it's a compact or concise binary object representation. This was something that I learned as part of doing this project, but it's a very concise binary representation of data. So if you don't want to use a lot of bytes, don't use JSON. But there's a nice thing about using JSON that I'll show a little bit later. Also, so there's that problem of having millions of events, but you also want to have a way to prune the logs so that you're not keeping history forever. There's a trade-off here. So if you're getting rid of portions of the log that you don't want anymore, you can no longer undo through those. So you have to be careful about your choices there. And of course, we talked about branching, but. So to be clear, this is not a database. There are no queries. I tried to add transactions for some reason a couple of months ago, and I backed away from that. So there are no transactions. I think I found the pattern that I was trying to use was just wrong when I needed to reach out for transactions. So there are no transactions. You get one event at a time. It's not a message queue. This is just an event store with lineage tracking. Some of you might be asking the question, well, why not use something that already exists? I could have used SLED or RedDB, but those are key value stores. There's no undo, redo. There's no lineage. SQLite and Postgres and other things, like I thought about those, but they don't do anything with undo and redo. And you really can implement a write-ahead log in any kind of database like SQLite. And you could do even checkpoints, you could even do snapshots and all of that, but it's not the right tool, I don't think. You would still have to implement undo and redo, and you still have to implement branching and all of that. But so an append-only log doesn't make sense. At one point, I had done undo as an append operation. So instead of using a head pointer to go back through the sequencing, I was applying events that would undo the event that it was trying to undo. So it was like the inverse. I ran into problems with that, with the, I can't remember exactly what it was, but I just ran into a bad experience with that. It was just much easier to say, let's just move this pointer. I think the issue there is that there were undo operations that impacted a lot more than just the event that was being undone. Like if you're deleting a track and that track has a lot of pieces to it that could each have their own events that are in the log, then undoing that and reversing it was pretty tricky. But yeah, so anyway, this is so I decided to try this out. I'm also kind of biased towards learning about how things work, and I'd always been curious about to write ahead logs, and so I was like, I'll give this a try and see if it works. If you need a database, don't use this. If you need a message queue, don't use this. Also, if your events are huge, if they're very large, don't use this. It's not a good idea. This is meant for kind of metadata tracking. So the audio files, those can be quite large, but those are stored separately. So it's kind of one of those things where you should use a blob storage for large objects like that. But for metadata, this works pretty well. And it's not meant for a distributed environment at all and no concurrency. This is single write or single process by design. We'll skip past that stuff. So the architecture of this is pretty straightforward. You just call this append function and you give it the event. And previously you would have configured codecs to do the translation from your event into a JSON object, and then that gets turned into an envelope. We'll look at what that looks like. And then that goes to the storage backend. So my hope was to implement multiple storage backends. Right now, I just have a file-based backend for this. But I was hoping to maybe think about a network version of this. I don't know if that's a good idea. I haven't really needed that yet, but so then the lineage is all taken care of behind the scenes as well, and then it hits the disk. So this is kind of what the structure looks like. There is a file that's missing here, the head file, which has the pointer to where it is. So the manifest file is just keeping some metadata around the segments and indexes and the snapshots. So the key pieces here are these segment files, and you can have segments that are either sealed or active. And the reason why I needed a sealed version of a segment or an active version of a segment is if there is a crash and you have all of these segment files, you need to, and if you don't have snapshots, you do need to iterate through each of the segments. But you also might run into a truncated disk write. And with a sealed segment, what that means is that there is a record at the end of that segment file that says, hey, I'm sealed, I'm good. So we know that there are no issues in that segment file. Also for segment files, I think this was kind of maybe me being too much of a geek. When I researched how databases do their write-ahead logs, and they do divide them up into segments like this. And if you go and look at the file systems for most databases, you will be able to find the segment files for them. Like if you need to do serious crash recovery with the database, you got to go use these files basically. So I wanted to try it out, but anyway, it works. Maybe it's not a great idea, but I had fun. The index is necessary because when you seal a segment, the index file gets created for that segment that basically maps event records or sequence numbers into byte positions into that segment, so you don't have to go search a segment. I'm not actually using that yet, but it is there. I thought I might need it at some point. I think it might be a tech debt that I could remove, but it's there. And then the snapshots, hopefully they speak for themselves. This is where you take an entire snapshot of the application state. The lock file, it's an advisory lock. I don't know if this works over network drives. I haven't tested that yet. The thought occurred to me a couple weeks ago, but haven't had a chance to try it out. But it does work on almost every operating system, and there's a Rust crate that provides an abstraction for that. And that's there so that you never have more than one process that's operating against the log. Lineage is for branching. I don't think we'll dive into that too much here. Cool. So this is what it looks like, really. I think the interface is not too bad. You just need to open up. You have to create a config which has a path to the file that you're trying to operate against. This domain event is an enum, and you just have to add the variants for the events that you want to go into the log. There are some use cases where you want to get a log that's in a replay mode or a recovery mode. But in order to start appending to it, you have to get a different type that you get from the finish replay. I'll talk about why that's the case. But yeah, it's pretty straightforward. You just append events whenever they happen. There are some tricky things when it comes to UIs, like you have to debounce, and if you have a drag operation on a widget, You don't want to write every single drag event there. So the application still has to, I forget what the technical term is for that, but it still has to figure out, just write the start and the end state, basically. Debounce, yeah, kind of, I guess debounce captures a part of that, yeah. But there's also, debounce is like if you're just doing a quick move. But yeah, anyway, yeah. So let's see, I kind of, we'll skip over this. Not super interesting. I think we have a better, yeah, so here's what the envelope looks like. So this is I think this is every single event follows this shape. And the reason for that is probably over-engineered, which, you know, when I'm having fun, I like to over-engineer. So can't do it at work. So there is a bit of overhead. I think it's about 100 bytes per event, which could be way too much in some applications. But for an audio app, for like a digital audio workstation application where you have tens of gigabytes of audio samples, I don't know if 100 bytes per event is that big of a deal. And besides, like with the compaction, it becomes less of a problem. Again, with compaction, there's a trade-off of how far can you go back in the history. Also, I figured I'm using the SRUG CBOR crate, but I just found out that it's archived, so I have to migrate to something else. But it works perfectly fine for me. But I do have some tools. So there's this dump tool, and this has been an indispensable tool. So I can actually tail a log while I'm using my applications that I'm developing, and it's been super helpful in debugging issues. But you can also pipe it through JQ. It's machine readable, so you can filter things out. And if you're just looking for something specific, I have had one wall that got, I think, close to a gigabyte in size, but that was from crazy mistakes that I had made. But I don't know that filtering is actually necessary. So every event goes through a CRC 32 check. Maybe over-engineered, but still, like we're talking about, you know, my music is important to me. I want to know, and you know, just being a technologist, I know how to know. So you can validate. You can use this tool to validate your logs to make sure that everything's okay. Also, super important during development. Maybe less important, but I don't know if you have an application that you're actually have end users using, maybe that's important to tell them that, hey, we've discovered that your file's been corrupted and we found out where the corruption was. What do you want to do with that event? Do you want to keep the stuff after it, right? So this is kind of what the wall looks like in the segment files. You know, you can add a track, or you can add a node, you can rename the track, you can change the master gain, you can change the theme of the application. Pretty simple stuff. Root is basically saying that there's nothing before this. I actually had a bug with not having that, so I had to add that in there. Seems kind of silly, but I guess I hadn't thought about it. But yeah, so every event points to its parent, and this is what enables the branching. Okay, yeah, so I think that's probably, the codec registry is a bit of a mistake on my part, I think. I wasn't sure when I was developing part of this, I wasn't sure if the application would want, I wasn't sure how much control the application would want over what actually gets serialized into the log. And so I had this codec registry so that if you wanted to have a custom encoder and decoder, you could register it with the system before you open your log. But it turns out that the only ones that I have are a binary codec, the CBOR codec, and the JSON codec. And so I probably should get rid of this arced-in payload thing and the send and sync and just have an enum. We talked about snapshots, so we'll skip over this. But yeah, the point is if you have a lot of events, it gets really slow. We talked about the segments. We talked about, they can be configured on the number of events or the size. We talked about crash recovery, and yeah, we already did that. Cool. So for some benchmarks, I think this was kind of cool. So applying a single event, I don't know if I trust these benchmarks, by the way. I am using Cargo Bench, I think, and this is all run on my laptop, and so maybe I was listening to music when this was happening, and so, but the magnitude is probably realistic. So without an f-sync, we're talking about 300 microseconds. But then if you want to force an f-sync on every event, you're going to pay a lot for that. And the thing that's critical here is that most, so you have a real-time thread in audio systems, and if you have an event that's coming from your audio real-time thread, that goes through the wall, you do not want to use f-sync because 10 milliseconds will skip 3 or 4 buffers that need to go to the audio hardware, and that sounds really bad. It gets crackly and poppy and not great. What most DAWs do in this type of a situation is they stop playback, but I don't have to stop playback. It just works. But for other situations, so this is why f-sync is configurable. So when you write an event, you can choose if you want f-sync to be enabled for that write or if you want it to be disabled. The payload.
Just for my question, maybe you could repeat it. Is f-sync a function of how much data you're writing?
So f-sync is.
Just to repeat the question.
Yeah. Okay. So is f-sync? Oh, is that okay? Yes. So is f-sync a function of how much data you're writing?
The time.
Yeah, the time. I don't know the answer to that. Yeah. So it's part of the problem with f-sync is that you're also calling out to the operating system, and so you're crossing into kernel, and you're saying, hey, I have this buffer that I've written stuff to. I want you to go and write this to disk, and then the kernel is going to say, oh, okay, I'm going to stop everything you're doing. Until I write this to disk because you told me that you don't want to move forward until you know this has been written. So it can be a function of how much you're trying to write. But just writing, just that process of getting into that f-sync space causes it has a big overhead. Yeah. So with no f-sync, you can see that the size of the payload does have an impact a little bit, but it doesn't look like it's super linear. It looks like it's sublinear. Let's see, what do we have here? Let me make sure that's everything there. So this is for doing a cold replay, so opening one of these projects from scratch. I'm getting about 356 events, 356,000 events per second. It's not too bad. But again, if you had millions of events, like that's a few seconds, and I don't know. I don't like waiting, and I think that anyway. So yeah, we should make that go fast. And so snapshots will help this here. The undo redo cycle is quite fast as well. Cool. I think we talked about f-sync. We can skip this just for time, but I am doing some testing here in addition to the benchmarking. I really wanted to hammer the snapshots to see how that had an impact on it. And then I did do this relocate functionality. So if you want to like move your log to somewhere else on the file system programmatically, totally doable, totally over-engineered, completely unnecessary because most move operations are atomic in most operating systems. But anyway, I got rid of that. So we talked about the operational tooling a little bit. And there is a way to recover. So if you have a log that does have some corruption, this will go ahead and fix it. You might lose data, but it will print out what is going to drop. So you'll know what you're losing. This is also available via the API. So if you are building a user-facing application, you can list out all of the events that they're losing, and they can decide what to do. I do like the envelopes. The thing that this solved for me is I can change my events now as I'm building different applications, and I don't have to care about the storage layer anymore. It's completely abstracted concern for me. So this has been perfect for me in that sense. Keeping a lineage in the manifest was super helpful. Building that dump tool early was a super big help because I could see what was going on. Yeah. Anyway, there are some things that I'm reconsidering, but I won't get into those for time. So for what's next, again, like damage reporting, it's there, but the UI, no, that's all right. Yeah. So right now it's just a log right now. I thought I did have some thinking that I wanted to do some cryptographic chaining and hashing. That was kind of silly. I implemented Git about a year and a half ago, and I thought, wow, that's so cool. Again, it's my free time, personal project. I can do what I want, but I didn't do that, and I'm not going to do that. I think that's silly. But the compaction isn't working yet. I need to implement that. I haven't needed it yet with the snapshots, but anyway, I do want to have an in-memory storage backend. I think that's super helpful for unit tests, and I have thought about doing a network backend. Something that's been on my mind is how to implement a CRDT in collaboration with this yet. I've tried a couple of times, and CRDTs are just hard to begin with. And the big problem is I haven't been able to map my domain onto which type of CRDT I would need to begin with. This should work for that, but that's the problem I really need to figure out how to solve is, and I don't know if that can be, or if it makes sense for that to be generalized into this crate. But I would like a network backend. That would be kind of cool. Yeah, so it's open source under the MIT license. This is the URL for it. To be honest, like creating an open source project was a bit nerve-wracking for me. It's a little scary. There's, I don't know why. But there it is. It's about 11,000 lines of code. A lot of it's test code. Yeah, if anyone's interested in taking a look or collaborating or criticizing, I'm open to all of them. So anyway, that's event-wal. Thanks.
All right, questions? Sorry, get my steps in.
Thanks, great talk. And I missed a part of it, so I just want to make sure that you covered like anything to do with like trade-offs between using fsync versus not using. Like you have the dump tool and the repair tool and all that stuff. Did you see like, I don't know, lesser guarantees by not using fsync versus the approach you took?
Yeah, I think I can't remember if I actually measured this, but I have never needed fsync. Different operating systems have different guarantees around when buffers will be written, and it also depends on when you fill up your buffer. So one thing that I'm not super clear on is if you do fill up a buffer, if an fsync is forced on you. I don't remember that detail. Without fsync, I think that you've got somewhere between 10 to 50 milliseconds of time that goes by before you're actually safe. I don't care. This isn't a transactional database with financial information, with a double accounting going on, right?
Buy a UPS and you're good.
Exactly, right? Yeah. It's a good question, though.
So when you take the snapshots, I imagine that takes a bit of time. Do you have to pause accepting new events into the write-ahead log? And is there a noticeable lag when that happens?
I haven't seen the lag, so I don't know. I haven't measured that. I think that would be a good thing to measure, even though I haven't seen it yet. But yes, it is all serial. There is no concurrency going on. So if you are going to write a snapshot, that stops everything. Yeah. So like from a GUI thread, I think for the two applications that I'm using this in, they both have UIs. Using eGUI, I highly recommend eGUI if you're building UIs in Rust. You don't want to block that UI thread. I'm still not doing this async from the UI thread, so it's all in the UI thread. I never see a block. So.
Cool.
Where can we find your music?
What's that? Oh, give me a few months. I'll have something released. Working on something right now.
experimented with F data sync instead of F sync?
I haven't. Nope.
All right. Oh, like flashing at me. Pick a color, man. Somebody's put their hand up in there. Oh, we do? Okay.
Oh.
Yep, we got it.
Oh, Daniel.
Yeah, me again. First of all, yeah, thanks for the awesome presentation. Really interesting project. I'm wondering why you would start from the beginning. I mean, great experience. I'm just wondering, like, I've been looking at an event sourcing library. Actually an event sourcing database written in Rust called SRUG. I've been thinking about, whether I should, implement like undo and redo functionality on top of that. So is there an impetus for starting from scratch as opposed to, just implementing extra features?
I completely agree with the premise of your question. I wanted to learn, so yeah, that was I think that when I was looking for a solution to the problems that I was having, I easily and probably would have been smarter to go and look for something that already did this, but I wanted to learn. I wanted to try this idea out, and I wanted to see what it took to get it to work. And so, yeah, the impetus behind that was just me being curious and hungry to learn. And that, to be honest, that's
awesome.
Yeah, that's one of my hesitations for putting out a crate like this is I'm not sure it adds value. It might just be noise. I don't know. But that was one of my hesitations, was like the reason why I really did this was because I wanted to learn, not that I saw a gap in the ecosystem. Somebody wanted to take a look at it, so I made it public. And I've been wanting to talk about it. And it's hard to talk about it without making it public. So yeah, I don't know. Maybe its future is it should go away. And that's okay. Or maybe its future is it doesn't change and I just use it for my toy projects. Or maybe somebody likes it.
The future is that it does very, very well.
And all of these outcomes I am completely okay with.
Nice. Oh, one more? All right.
I was just going to say, you should absolutely put it out there. If you think it's not ready and don't want people to use it, sure, don't take a crate game or anything. But the other thing that's great about having your code on GitHub is every time there's a Rust release, the Rust project runs all of the code that it can Rust on
really?
On GitHub through the compiler, and they'll drop by and say, hey, this is going to break, here's a fix for it.
Wow, that's cool.
Very nice.
The rest of my code is going up now.
Yeah, those are called creator runs. So if anyone is interested in learning more about how the compiler is built, you can look up how to do creator runs. It's pretty amazing stuff. All right. Thank you.